Hello, welcome back to Mr. Miles Maths. Today we're going to be looking at algebraic simplification, in particular addition and subtraction. It's just a fancy way of saying adding and subtracting kind of letters. We'll get straight into this. So fully simplify the following algebraic expressions. Remember, algebraic expressions or algebraic terms that are within that expression, it's just a way of saying letters and numbers. A particular term, for example, in that first question here, 4x is a term and plus 5x is a term. They're what terms are. We'll do a little bit more on that later, but I don't want to overcomplicate it to start with. So the first thing we're going to look at is just adding letters together, the same letter. We can only ever add the same letter together as well. We can't add different letters. So 4x plus 5x, this is simply the same as 4 plus 5, but I've got x's, so the answer is just going to be 9, and because it's 4x plus 5x, the answer will just be 9x. So it's as simple as that. If you're adding and subtracting numbers and you're good at that, you're well aware of your positives and negatives, there's no reason why you shouldn't find this relatively straightforward. 3y minus 7y. Again, the crux of this is just to do 3 minus 7, which is minus 4. But because they're y's, we're going to end up with minus 4y. And remember, you can pause the video at any time you like. If you need to write the questions down, I do strongly recommend you write things down. It certainly helps to practice this. Or if you want to pause it and then have a go yourself and then look at my answers, then that's fine too. Question 3, minus 3a plus 8a. Pay close attention to the signs here. We're starting at minus 3, there's minus 3 plus 8, and that will give us 5. And because we're dealing with a's, it just makes 5a. And remember, the whole way through this, 9x or minus 4y or 5a, that just means that number multiplied by that letter. So 9x is just a shorthand way of writing 9 multiplied by x. We don't know what x is, but we can just write it as 9x to make it a little bit simpler for us. Number 4. This time we have 3 terms, so we'll have a couple of calculations within this. So the first thing we're going to do is look at the first 2 terms. They're all the letter C, so we can add them all together and do minus 2 plus 7, which is 5, and store that in our head. So we're going to have 5, and then we're going to do minus 4 after that. So 5 minus 4, which is 1. Now, some people like to write 1c here. We're always trying to write this as simply as we can, because 1 times anything, whether it's 1 times 7 or 1 times x or 1 times a million, it doesn't matter what it is. Make sure I've got the right number of zeros there. We always end up with that same thing again. So 1 times c will just be the same as c. So to try not to overcomplicate things, we'll just write this always without the number in front. Write it as 1c. Fancy word for number in front is the coefficient, but that just means the number assigned to that letter. So the coefficient here would be 1. Coefficient in number 3 here, coefficient of a would be 5. Coefficient of y would be minus 4. Hopefully you get the idea. Okay, number 5. So this time we've got 4 terms. So again, we can work through this. They're all d's, so they're all going to add and simplify together or subtract. So the first thing to consider is 4d minus 2d, which is 2d, plus 6d gives us 8d, and then minus 9d is 8d minus 9d is minus 1d. And again, I won't write the 1 in, because it overcomplicates it. 1 times anything can be the same thing, so minus 1d, are better off writing minus d. And then finally, 3w minus 2w is 1w, or just w. So w, and then minus 7w, the same as 1 minus 7, which is minus 6. So this is minus 6w. Again, there are some simple examples of algebraic simplification, addition, and subtraction. And if we scroll down a little bit, we're going to look at some slightly more complicated ones, but if you can do these, you can pretty much do anything. It's always being careful with the signs and making sure you add and subtract what we call like terms. I've kind of put it here. You can only subtract like terms. Okay, the like bit is really important. And by like, we just mean ones that have exactly the same letters in them. It doesn't matter which order they're in. It doesn't matter with the powers, so long as the power is with the correct letter. We'll come on to an example so you see what I mean. But we should always only add like terms. We can't add different letters. We can't add x's to y's. So let's look at some examples of this, and then we'll be done. So we've got number 7 here, 5x minus 3y. This is a bit of a trick question. Because they're different letters, these will not simplify. They will not add together. I cannot add x's and y's because they represent different things. So this will just stay the same. Whereas number 8, they're all y squareds. Because they're all y squareds, I can add all these terms together. So 4y minus 9y, 4y squared, sorry, minus 9y squared is the same as 4 minus 9. That's my calculation. So minus 5, keep that in your head. Plus 3 is minus 2. And because they're all y squareds, my answer would be minus 2y squared. Notice I'm not squaring the 2, I'm not squaring anything, it's the y that's squared. It just tags along with the y, don't make it more difficult than it is. This one always throws people when you've got letters the opposite way around. The best way of thinking about are these like terms, because they are the same letters, they're just in a different order, and does that count or does that not count? And the quickest way probably to look at it is to look at something, well, AC means A multiplied by C, and CA means C multiplied by A. So we've got to ask ourselves in this kind of format, did they give us the same answer? And we can't always check with numbers, but a quick little thing to make you hopefully believe that this is true, these are actually the same thing, is if I multiply 2 by 3, I get 6. If I switch that round and do 3 times 2, I do get the same answer, it checks out. I know that's only one example and there's an infinite number of examples we could look at, but AC and CA are the same thing. So these are actually like terms, even though they look very slightly different. Just rub that out. So we can actually add 4AC and 3CA, which will give us 7AC, or if you like, you can write 7CA. We tend to keep things alphabetical in maths as well, if we can, not always doable, but I tend to keep it alphabetical, and that means I'd write 7AC here, but if you're at 7CA, absolutely fine as well. Scroll down a little bit. So number 10, a little bit different, and the important thing here is that we focus on terms, and every term in maths has a sign. So by a term, I mean anything that has a number and a letter. So 2x is a particular term, minus 3y is another term, 5x is the kind of third term here, and minus y. And remember, every time, hopefully you notice, every time I look at a term, I say the sign associated with it. And that's really important to get into that habit, so that you know that I'm always looking out for positives and negatives. A lot of time, people who are kind of good at maths and people who are not so good, is because they pay very close attention to the signs, and that means that they get the correct answers. That's a big thing that happens, and a lot that I see a lot of. People don't pay attention to the signs. Some people like to use bubbles and boxes to do this. They might put bubbles around the x terms and then boxes around the y terms, so you can really highlight. When you do that, include the sign, but it's entirely up to you how you approach this. You might do that to start with, get more confident, and then not need the hints anymore. Or you can kind of separate terms out by looking at the four. There are 4 terms in this: 2x, minus 3y, plus 5x, and minus y. They're my 4 terms. And terms are separated by the pluses and minuses. That's kind of, when I see a sign, like a plus or a minus, that's the start of a new term. Hopefully that makes sense. If you get your head around terms and signs, you'll find maths a lot easier in general. So let's get on with this, stop waffling about it. So we've got 2x here and 5x, they're my x terms, and do these separately. So do the x's, get it written down, clear them out of the way, because then you don't have to remember everything as your final answer. So where are my x's? Get them sorted, get your answer down. So 2x plus 5x is 7x. And then where are my y terms? My y terms are minus 3y. Notice how I include the sign, minus y. So this is minus 3 minus 1, which gives me minus 4, and their y's, so minus 4y. Number 11. Okay, we've got, again, might help to separate terms out. My red pen works. There we go. So there's 4 terms in this question: the minus 4a, positive 3a, positive 2c, and minus 5a. And if you include all those signs in your calculations, it will give you the sign in your answer. Rather than thinking, am I adding or subtracting here? It will give you the sign. And hopefully you'll see what I mean here. So minus 4a plus 3a is minus 1a, just minus a. So it's minus a, minus 5a is minus 6a. And it gives me minus 6a, it gives me the sign. So I can just write that down. I don't think, am I adding or subtracting? And then there's no other c's. So the c will not mix. Non-mathsy word for you. It will not mix, it will not simplify with anything. So the 2c just stays that way around. And some people ask, can I write this differently? And the answer is yes, so long as you keep the sign with the correct term. The minus 6a is minus 6a. It's got to stay as minus 6a. I can't go switching terms and saying, oops, this would be wrong. It would be a different answer. So the sign has to be correct with the correct term. Number 12. So here we have 4x squared plus 2x minus 3x squared plus 7x. We cannot mix x's and x squareds when we're adding and subtracting. They are very different. It's like an x and a y. So we can only mix the x squared with other x squareds. And we can only mix the x's with other x's. Got some highlighters in difficult places. There we go. I can't remember what that was now. Doesn't matter. Let's just put 7. Let's put 6 in. If I've changed that question, sorry, doesn't matter. Let's go with this one. So 4x squared minus 6x squared, which is minus 2, and because they're x squared, it's just going to stay as minus x squared, so minus 2x squared. And then the other one is plus 2x and plus 7x, which will make plus 9x, and it gives me that sign. So I don't have to think, am I adding or subtracting? It gives me plus 9x, so the answer is I will be adding 9x on. These are all x terms. So here, 15 minus 12 is 3x. 15x minus 12x is 3x. Minus 5x is minus 2x. And plus 2x will give me 0x. And again, similarly to 1, 1 times anything is anything, 1 times a million is a million, but 0 times anything is always 0. So it's 0x, 0y, 0 anything. Because I'm multiplying by 0, hopefully we know we always get 0 as a result of that. Okay, then we've got some little tricky ones at the end which catch people out, where we've got different powers. Now, the powers do matter. The order of the letters don't, but the powers do. So if I'm looking at this term, 2x squared y, I need to identify anything that's got an x squared and a y in it. Not y squared and x. It's got to be square with the x and a y by itself. So as I scan through this one here is the same because it's got an x squared. So the powers are the same, x squared, and y is just y. So they will be like terms. This one is also a like term because this x is squared and the y isn't. But if the y was squared, it would be different. Okay, you might want to pause and slow down a little bit here if you're finding it too quick. But x squared y, x squared, they are the same thing because just the x squared and the y isn't. So they're all like terms. So I've got 2 plus 3, which is 5, and 5 minus 4, which is 1. So it'll be one of those. Again, I could write y x squared. I'm going to keep it alphabetical for now. And there's no other y terms. So the 5y just tags along. And then the last one, again, be very careful here with where the powers are. So cd squared, I'm looking for other terms where the c is not squared and the d is squared. So this one here, c squared is not going to be the same. This one here, c is squared, not going to be the same, but this one will be the same. Minus 9d squared. Because I've got d squared c, sorry, because I've got d squared and c in. So we've got 2cd squared and this, minus 9, which is minus 7. So the d isn't squared and the c isn't. And then these two, the c is squared and the d isn't. So here we'll have minus 3 plus 4. So these are like terms again because of the powers. Minus 3 plus 4 is 1. So I'll just get 1. And the c is squared and the d isn't, so I could write c squared d or dc squared. That'll be fine. I'm just going to throw in one more question, which I hadn't written here as well, just to prove my point of signs. So when I have something like this, again, we're looking for like terms, so the letters where the letters are exactly the same. So there are 2x terms, the 4x, and the minus 2x. So they will simplify to give me positive 2x. And get rid of the highlighter. Positive 2x. And with this one, I've got minus 3y, minus 8y. And always include the sign in your calculation, always include it in your thought process, always say it, because then you'll get used to looking for it. But because this is, people always think, oh, am I adding or subtracting here? Don't worry about that. The sign will take care of itself if you do the calculation correctly. Minus 3 minus 8 is minus 11. It gives you the sign minus 11, and you don't have to think about adding or subtracting. That's algebraic simplification, addition and subtraction. Look at the bottom in the comments, please, if you want any kind of questions on this. There will be a times and dividing one. And please like the video and subscribe to my channel if you found this useful and helpful, and keep watching out for more videos. Thank you.